Okay, so for this section we're going to be learning how to factor when a equals 1. And you remember that a is the coefficient on top of the ax squared plus bx plus c pattern that goes along with quadratic equations. So when we're saying when a equals 1, that's what we're talking about. So let's look at vocabulary. Our vocabulary, a factor is a verb, so like you're going to actually do it. Remember, verb is an action, meaning to write an expression as the product of its factors. So if you're going to factor something like 6, you would factor it into 2 times 3. Of course, we're not going to be factoring things quite that easy. We're going to be factoring quadratics. Okay? And the leading coefficient is the coefficient, which means the number attached to a variable of the term with the highest power. So if we have this, the leading coefficient is A. In other words, it's the most important coefficient, they think. So pause now and make sure you've got these written in your notebook or your workbooks, either one, or both. All right, so let's factor this. Actually, I think factoring is kind of fun, but notice that it's not an easy number like 6 or 4 or something. It's x squared plus 10x plus 24. And when we factor, we're going to come up with 2 quantities multiplied together would give you that. So when we FOIL, it's kind of like factoring is like unfoiling. So when you FOIL and you get your first 2 numbers, you multiply those together to get the first number. So it would have to be an x and an x, because that's how you get the first x squared. Okay, so, and then notice all of the signs are positive. So we're going to put positive signs in there. Now, in order to figure out our last 2 numbers, you think in your head, what times what is going to equal 24? And the same 2 numbers added together will make 10. So think and think and think, and maybe you'll come up with 6 times 4 is 24, and 6 plus 4 is 10, and you have a 6 and a 4. And that's the factored form of that. How do you tell if x plus 6 times x plus 4 equals the x squared plus 10x plus 24? Well, you FOIL them. X times x, x squared. X times 4, 4x. 6 times x, 6x. And the last 2, 6 times 4, 24. Combine like terms, x squared plus 10x plus 24, and it indeed is the same as the original. So you're factoring, if you notice, you're unfoiling, so when you check it, you can FOIL it back. That was amazing fun. All right, factor the following. So, remember that the very first thing you look for when you factor is the greatest common factor. See if you can pull out a greatest common factor. Can you? Looks like maybe 5y squared would make 5 times y, and so maybe I can pull out a 5 out of here. Then I would have left a y squared minus 9. Okay? And so, if I look next, I can look and I can find that I have a difference of squares. Y squared is a square, and negative 9, or 9 is a square, and then the difference means subtract. So the tricky part is when you have a difference of squares, it's kind of a shortcut. I mean, we'll still FOIL it out, but they kind of give you like a hint that you have to have your signs different, and then 9 divides into 3 and 3. Well, what happened to the middle term? Didn't we used to have like y squared plus something y minus 9? Well, in the difference of squares, it's a kind of a unique situation. Let's FOIL them and see. Y times y squared. Y times negative 3, negative 3y. 3 times y is positive 3y. And 3 times negative 3, negative 9. Well, if you look right there, those will cancel out. And all you're left with is y squared minus 9, which is what you had in the first place. So that's the cool thing about difference of squares. If both of the numbers, like y squared, if this is a square, which it is, y times y, and you have a minus sign, and that's a square, 9 is 3 times 3, then you know right away it would be y plus 3, y minus 3. And the only way that you get those is by FOILing them out enough times that you'll remember when you see a difference of squares that you don't have to do anything, you just immediately go right to the pattern. Now, it won't happen the first 2 or 3 or maybe 16 times you do a difference of squares, but eventually you'll remember because you won't want to do all the work. Okay, slide 5 says, we're looking at this polynomial right there that represents the area of a rectangle. So again, we're finding length and width, and what they want us to do is take this polynomial and split it into length times width. Doesn't matter which one's length, doesn't matter which one's width. So if I look at the first term, the x squared, I know I have x and x, because that's how you get x squared, right? And my last term is a negative 8. So in order to get that, when I multiply, I have to have 1 plus and 1 minus. Doesn't matter if you put it first or second, but it will matter what number attaches to it. So let's look and say to ourselves, what times what is negative 8? And the same number plus the same number is positive 7. So if I'm going to find negative 8, it would be something like negative 2 times 4, or 2 times negative 4. 8 is, let's see, negative 1 times 8, or 1 times negative 8. Do any of those add up to 7? Right there. So you have negative 1 and 8, and negative 1 and 8. Double check, negative 1 times 8 is negative 8. Negative 1 plus 8 is 7. Now which one has to go with the positive? The 8, and the negative goes with the 1. That's how you factor. It's kind of fun once you get the hang. Okay, and here is your difference of squares. I'm so glad they give it to us now instead of when I was just teaching you a minute ago. But now we look and we see that y squared is y times y, which is a square. 100 is 10 times 10. So then I go like this. I know the y's go there. Because it's negative, 1 is positive, 1 is negative, and if that's 10 times 10, you have 10 and 10. If you FOIL it back, instead of y squared minus 100, that's what we want to get. So we take y plus 10, y minus 10, and FOIL. Y squared minus 10y plus 10y minus 100. These fall out, and you're left with y squared minus 100. Did you recognize at the beginning that it was a difference of squares? If you did, that's excellent. If you didn't, you will. Okay? Factoring can be difficult, so I'd like you to just start your homework and see how well you do, or just go to class, whichever one your teacher says. If you have trouble, you might want to watch these YouTube videos, or be sure to ask questions in class if you have questions.